In the mid-1970s, Mercedes-Benz was facing a problem that most American manufacturers didn't even recognize yet. Fuel prices were rising, emissions regulations were tightening, and customers were beginning to demand efficiency without sacrificing longevity. Diesel engines were no longer just industrial tools. They were becoming everyday transportation. But most diesel engines of the era were crude, noisy, and short-lived when placed in passenger cars. Mercedes-Benz believed that didn't have to be the case, and instead of designing an engine that merely met regulations or chased fuel economy numbers, they chose to do something far more ambitious. They decided to build a diesel engine that could last longer than the car around it. That engine became the OM617. When the OM617 entered production, it was not meant to be legendary. It was designed as an evolution, an improvement over the earlier OM617, which had already earned a reputation for durability but lacked power. Mercedes engineers knew that if diesel was going to succeed in passenger cars, it needed to deliver more torque, smoother operation, and better drivability, all without compromising the reliability that defined the brand. The answer was a 5-cylinder diesel with conservative tuning, massive internal strength, and an almost obsessive focus on longevity. The OM617 was a 3.0-litre inline 5-cylinder engine, built from thick cast iron, not just in the block, but in the cylinder head as well. At a time when many manufacturers were experimenting with aluminum to save weight, Mercedes went the opposite direction. Weight was not the enemy. Heat and stress were. Cast iron allowed the engine to absorb thermal expansion evenly and resist warping under sustained load. The result was an engine that could run hour after hour without breaking down its own structure. Internally, the OM617 was built like an industrial engine scaled down for automotive use. The crankshaft was forged steel, massively overbuilt for the power levels it was asked to handle. Bearing surfaces were wide and generously lubricated. Pistons were designed with thick crowns and conservative compression to avoid thermal stress. Nothing about the engine was pushed to its limit. Every component operated well below its maximum capacity, and that margin is what made the difference. Fuel delivery came from a purely mechanical Bosch inline injection pump, one of the most reliable fuel systems ever installed on a road-going diesel. There were no electronics, no sensors, no control modules deciding how the engine should run. Timing was mechanical. Fuel quantity was mechanical. If the engine ran poorly, the solution was adjustment, not replacement. This simplicity meant the OM617 could be maintained anywhere in the world with basic tools and mechanical understanding. When turbocharging was added in the late 1970s, Mercedes did not chase aggressive boost or dramatic horsepower gains. The turbocharged OM617 was still modest by modern standards, producing power figures that seemed almost conservative even for the time. But torque delivery improved dramatically, and drivability increased without placing undue stress on the engine. Exhaust gas temperatures remained manageable. Internal pressures stayed within safe limits. The turbo was there to assist, not dominate. This conservative approach confused some critics. On paper, the OM617 looked underpowered. Acceleration was slow, top speed was modest, but Mercedes was not building an engine for spec sheets. They were building one for owners who planned to keep their cars for decades. and those owners quickly discovered something remarkable. These engines did not wear out in the way most engines did. High-mileage OM617 engines did not consume oil excessively. Compression remained strong even after hundreds of thousands of miles. Cold starts stayed reliable. Valve trains showed minimal wear. Many engines crossed 300,000, 500,000, even 1 million miles without major internal repairs. When maintenance was performed, it was usually peripheral. Injectors were serviced, glow plugs were replaced, timing chains were inspected. The core engine remained intact. The OM617 also earned a reputation for tolerating abuse. Poor fuel quality, infrequent oil changes, extreme temperatures, and long idle times did not immediately destroy it. Taxi fleets in Europe ran these engines continuously, often 24 hours a day. In North Africa and the Middle East, they ran on fuel that would cripple modern diesels. In cold climates, they started reliably when gasoline engines struggled. The engine did not complain. It simply adapted. By the early 1980s, something unexpected had happened. The OM617 had developed a reputation that transcended Mercedes-Benz itself. It became known as the diesel engine that could not be killed. Owners spoke of it less like a machine and more like a companion. Cars rusted away, interiors fell apart, suspensions wore out, and still the engine kept running. This was not an accident. It was the result of engineering philosophy. Mercedes engineers believed that an engine should outlast trends, regulations, and even the vehicle it powered. They believed that reliability was not achieved through complexity, but through restraint. The OM617 embodied that belief more completely than almost any engine before or since. And yet, its greatest test was still ahead. The true test of the OM617 came as the automotive world began to change around it. By the early 1980s, emissions regulations were tightening across Europe and North America, and many manufacturers found themselves struggling to adapt older engine designs to new requirements. For most diesel engines, these changes marked the beginning of declining reliability. Additional systems increased heat, complexity, and failure points. But the OM617 endured largely because it had been designed with such wide margins from the beginning. Unlike engines that were already operating near their limits, the OM617 had room to absorb change. Its low specific output meant that added emissions controls did not immediately overwhelm the engine's thermal or mechanical capacity. Injection timing could be adjusted, fuel delivery could be refined. Even as regulations evolved, the engine continued to operate within safe boundaries. Where other diesels suffered premature wear or catastrophic failure, the OM617 adapted quietly and carried on. This adaptability is one reason the engine found such widespread use beyond private ownership. Taxi fleets became its natural habitat. In cities across Europe, Africa, and the Middle East, Mercedes sedans powered by OM617 engines ran day and night, often accumulating mileage at a rate that would destroy lesser engines in a few years. These cars were rarely driven gently. They idled endlessly, carried heavy loads, and were maintained only when absolutely necessary. And still, the engines survived. In many regions, the OM617 became more than transportation. It became infrastructure. Entire taxi economies were built around its reliability. Mechanics learned its quirks intimately. Parts networks developed organically. Knowledge was passed down through generations of technicians. The engine's simplicity allowed it to thrive in environments where modern diagnostics and specialized tools were unavailable. As long as fuel and oil were present, it would run. The OM617 also developed a second life outside of passenger cars. As vehicles aged and chassis wore out, engines were removed and repurposed. They found homes in off-road vehicles, boats, generators, and industrial equipment. Their compact size and mechanical simplicity made them ideal for conversions. In remote areas, OM617 engines powered water pumps, agricultural machinery, and makeshift power systems. They became the heart of projects that demanded reliability above all else. What is striking about these secondary uses is that they often pushed the engine harder than it was ever intended to be pushed. Continuous high load, limited cooling, and improvised installations would have destroyed many automotive diesels. The OM617 absorbed the abuse with the same quiet resilience it had always shown. Failures were rare, and when they occurred, they were usually repairable. As the 1990s approached, diesel technology began moving decisively away from the philosophy that created the OM617. Electronic controls became standard. Injection pressures rose dramatically. Power outputs increased. Engines became lighter, more efficient, and far more complex. These changes delivered impressive performance and cleaner emissions, but they came at a cost. Service life shortened. Repairability diminished. Engines became systems rather than machines. The OM617 stood in stark contrast to this new direction. It had no interest in peak output or rapid acceleration. It did not attempt to impress. It simply continued to run. Owners who transitioned from older Mercedes diesels to newer designs often noticed the difference immediately. The newer engines were quicker and quieter, but they demanded attention. They were less forgiving. Small problems became expensive ones. The old OM617, by comparison, felt almost indifferent to neglect. This indifference is what cemented its reputation. The engine did not rely on perfect conditions to survive. It assumed the opposite. It assumed imperfect fuel, imperfect maintenance, and imperfect operation. That assumption shaped every design decision. Thick castings resisted heat. Conservative tuning prevented overstress. Mechanical systems avoided dependency on fragile components. Nothing was optimized for minimum material or maximum efficiency. Everything was optimized for endurance. As production eventually ended, Mercedes-Benz moved on, embracing newer technologies and modern diesel architectures. But the OM617 refused to disappear. Decades later, it remains a fixture in workshops, farms, and garages around the world. Engines that were built in the late 1970s and early 1980s continue to operate daily. Many have never been opened. Others have been rebuilt once and returned to service for another generation. What makes this longevity remarkable is not just the mileage, but the consistency. The OM617 does not deteriorate quickly. It ages slowly. Performance declines gently, not abruptly. Wear accumulates predictably. Owners learn its rhythms and respond accordingly. It becomes less like a disposable component and more like a long-term partner. In an era where engines are often viewed as consumables, replaced rather than repaired, the OM617 represents something fundamentally different. It represents a time when engineers were allowed to prioritize durability over cost reduction and longevity over marketing. It reflects a belief that a machine should earn its place through years of service, not short-term performance metrics. The OM617 was never the fastest diesel nor the most powerful. It never needed to be. Its achievement lies in the fact that it simply refused to wear out. It survived trends, regulations, and technological shifts without losing its core identity. It proved that restraint, margin, and mechanical honesty could produce something truly timeless. In the end, the legacy of the OM617 is not measured in horsepower or innovation, but in trust. It is remembered as the engine that started every morning, that ran when others failed, and that outlasted the vehicles it powered. And that is why, decades after it first turned a crankshaft, the Mercedes-Benz OM617 is still running.